Hello grade 10s and welcome to another mathematics lesson. Now these are practice questions for the final examination in paper 1. Okay, so please note that the different parts will be what you are to expect in different questions. Okay, so part 1 is commonly algebraic expressions, part 2 is common question 2 in a paper 1 question paper, sorry. Question 1 is commonly algebraic expressions. Question 2 is commonly equations and inequalities. Question 3 is commonly number patterns, right? That's how they will be structured. But please note that with mine, there will be a little bit of overlap. Okay. Please take this. I modified it from past exam papers. Number 1 states, given a is equal to, in the numerator you have square root of x plus 5 over, in the denominator you have x minus 7, where x is an element of negative 6, negative 1, 4 and 7. Choose from the given set of numbers a value of x for which a will be undefined. Now please remember that undefined means that the denominator must be equal to 0. So x minus 7 is equal to 0, x is 7. (1.2) equal to negative 0,25. Now when it's negative 0,25, we have to square root of, let's start with negative 6 plus 5, negative 6 minus 7. Getting math error? Aha, negative 6 plus 5 is negative 1. Square root of negative 1 is non-real. Then we move to negative 1, negative 1.4, which is negative 0,25. So in order for a to be negative 0,25, x must be equal to negative 1. Okay, non-real, we've already gotten this. Remember, when it was negative 6, in the numerator we're going to have square root of negative 6 plus 5, which is negative 1. We know that the square root of a negative number is non-real. So, negative 6. Rational, remember rational, it can be written in the form a over b as a fraction. Now we have 7, negative 1, negative 6. Let's try 4. Negative 1. Negative 1 is negative 1 over 1. So we can take 4. But please note that examiners will also accept x is negative 1. Because when x is negative 1, it's negative 1 over 4, which is still in fraction form. Okay. Number 2 states, factorize the following algebraic expressions fully. Roman numeral number 1, we have 30ax cubed minus 120ax. 120, the bigger number is 120. 120 divided by 34. So 30 rather is a common factor. Now we move to variables. We have a, and then we have x cubed and x. Now we know that if it's not written, the exponent is 1. My mistake. Okay. So this is going to be 30ax. 30ax cubed divided by 30ax. 30 goes, a goes, x to the power of 3 minus 1. 3 minus 1 is 2 minus 120ax divided by 30ax. 120 divided by 30 is 4. A cancel each other out, x cancel each other out. So in the brackets you have x squared minus 4. But you should notice that in the bracket you have a difference of 2 squares. So this is going to be 30ax square root of x squared is x. Square root of 4 is 2. Then one bracket will be positive, the other will be negative. Roman numeral number 2, you have 2cd minus 4c plus 2d minus 4. So by inspection, we should say that the common factor of a number is 2. (2cd divided by 2) the 2's will cancel each other out. You have CD minus 4C divided by 2. You have 4 divided by 2 is 2 times C is 2C plus 2D divided by 2. The 2's will cancel each other out. You have D minus 4 divided by 2 is 2. Alright. Now in the bracket you have C's as well as numbers. Let's factorize them according to C's. Let's take out C in the first two. CD divided by C, the C's are gone. You have D minus 2C divided by C, C's are gone. You have 2 plus, now if it's like this, we can just group them like this because it will be 1, right? 1 times D is D, 1 times 2 is 2. So 1 in bracket, D divided by 1 is just D minus 2 divided by 1 is 2. So as we can see, we have a repeating bracket which is D minus 2. So it's going to be 2. Coefficient of the first one is C plus 1. Coefficient of the second bracket. And then you write the repeating bracket, D minus 2. I hope that wasn't too challenging. Okay. Roman numeral number 3. We have negative 3e squared minus 72e minus 429. The coefficient of the squared is negative 3. But in the calculator we use 3. Let's use the factors of 72. If there is 3, there it is, there's 3. Now let's see the factors of 429. If there is 3, there's 3. So remember, in the calculator we use 3, but here it's going to be negative 3. Negative 3 squared divided by negative 3, they are gone. You have e squared. Negative 72e divided by negative 3. Negative 72 divided by negative 3. Positive 24. So it's positive 24 e. Negative 429 divided by negative 3. Plus 143. Now in the bracket we can see that it's a trinomial, quadratic trinomial. Now, okay, we look at the factors of 143. It's 11 times 13. 11 plus 13 is 24, which is the middle term. So, negative 3, 11, 13. E. Everything's positive, so there will be positive in both brackets. Okay, I hope that makes sense. Roman numeral number 4, you have 48 cubed plus 10,985. Okay, my mistake. 40. 2 cubed times 5, and then 10,985. 5 times 13 cubed. So the common factor is 5. So this is going to be 48 cubed divided by 5 8h cubed plus 10,985 divided by 5, 2,197. So we know that 8 is a perfect cube, or you can prove it if you don't know it. The cube root of 8 is 2. The cube root of 2,197, 13. So as we can see, cube root of 8 is 2, cube root of h cubed is h, plus cube root of 2,197 is 13. Now we have sum of two cubes. Remember, how do you simplify? This is going to be 5. In the first bracket, you take what is inside. So it's going to be 2h plus 13. Now, second bracket, you're going to say square root of, you're going to square this. So 2h squared is 4h squared. Because it's plus here, it's going to be minus. Then you multiply them. 2h times 13 is 26h. Then plus 13 squared is 169. I hope that makes sense. Number 3 states, simplify the following fully. My mistake. 3.1, open bracket, 2x plus 7, close bracket, open bracket, 4x squared minus 14x plus 49, close bracket. Okay, so 2x times 4x squared is 8x cubed. 2x times negative 14x is minus 28x squared. 2x times 49 is plus 98x. 7 times 4x squared is plus 28x squared. 7 times negative 14x, so 7 times negative 14, negative 98, so it's going to be minus 98x. 7 times 49, 343, so plus 343. Now you take the like terms. Okay, 8x cubed, there's no one like it, it's the only cubed, so it's 8x cubed. Now the x squared, you have negative 28x squared plus 28x squared, that's 0. Now the x's, you have plus 98x minus 98x, that's also 0, plus 343, that is the only constant. Okay, I hope that makes sense. Now in an exam, please don't cancel them like this, just rather leave them as they are and then write the final answer like this. I'm just showing you that they amount to 0. 3.2, 5x squared plus 20x plus 20 over x squared minus 4 plus 2x squared minus 26x plus 24 over x squared minus 3x plus 2. So in the numerator, the common factor is 5. 5x squared divided by 5, x squared plus 20x divided by 5, 4x plus 20 divided by 5, 4. X squared minus 4. In the numerator, the common factor is 2. 2x squared divided by 2 is x squared minus 26x divided by 2 is 13x plus 24 divided by 2, 12. X squared minus 3x plus 2. Okay, now you factorize everything. Factors of 4 is 2 times 2. 2 plus 2 is 4. So it's going to be, everything is positive, x plus 2, x plus 2. Difference of two squares, square root of x squared is x, square root of 4 is 2. One will be positive, one will be negative, plus 2. Can we factorize this? Factors of 12, 12 times 1, and then 12 plus 1 is 13. So yes, so x, 12, 1. Well, negative, so everything will be negative. Then below, x squared minus 3x plus 2. Factors of 2, 2 and 1. 2 plus 1 is 3. So you can also factorize 2, 1, x. Negative, positive, so negative, negative inside the brackets. Now we cancel the ones that are repeating in the numerator and the denominator. In the first, x plus 2, x plus 2. In the second, x minus, my mistake, oh no, x minus 1, x minus 1. Okay, so you have 5 times x plus 2 over x minus 2. 2 over x minus 12 over x minus 2. Okay, same denominator, so you can just add the numerators. So we're going to have x minus 2. 5 times x is 5x. 5 times 2 is positive 10 plus 2 times x is 2x. 2 times negative 12 is minus 24. Then, like terms, 5x plus 2x is 7x. 10 minus 24 is minus 14 over x minus 2. 7 is a prime number. Factors of 14, 2 and 7. So we can factorize the numerator. Common factor is 2. It's actually 7. 7x divided by 7 is x minus 14 divided by 7 is 2 over x minus 2. As we can see, we have another repetition here. So the final answer is 7. I hope that wasn't too challenging. Please grin and bear with it. Okay, 3.3. We have 15 to the power of 3x plus 4 over 3 to the power of 3x minus 2 times 5 to the power 3x plus 6. 15 is 3 times 5. So there's 15, we're going to put 3 times 5. To the power of 3x plus 4 over 3 and 5 are prime numbers, so 3 to the power of 3x minus 2 times 5 to the power of 3x plus 6. Then we use the distributive exponential law. 1 times 3x plus 4 is going to be 3 to the power of 3x plus 4 times 1 times 3x plus 4, 5 to the power of 3x plus 4. 3 to the power of 3x minus 2 times 5 to the power of 3x plus 6. I hope that is clear. Now we can take the same basis. Just going to leave some space so that it's clear. In the numerator, 3 to the power of 3x plus 4 minus, denominator we have 3x minus 2 times 5. In the numerator, 3x plus 4 minus, denominator 3x plus 6. So this is 3 to the power of 3x plus 4. Negative times positive minus 3x. Negative times negative plus 2 times 5 to the power of 3x plus 4. Negative times positive minus 3x. Negative times positive minus 6. Like terms, 3x minus 3x is 0. 4 plus 2 is 6. So 3 to the power of 6 times 5. 3x minus 3x is 0. 4 minus 6 is negative 2. So this is 3 to the power of 6 over 5 squared. So it is 3 to the power of 6. 729 over 5 to the power of 2, 25. Okay, I hope that wasn't too much for you, but if you practice, you'll be able to get them. Number 4 states, determine the numerical value of, open bracket, 5r minus 4s, close bracket, squared. If it is given that 25r squared plus 16s squared is equal to 8, and rs is equal to negative 1 over 5. Some of you here may be thinking simultaneous equations. That is the long method. Okay, but first I want you to expand this, right? That's the first step. 5r plus, oh sorry, minus. Okay, minus big. 5r minus 4s squared. Repeat the bracket twice. Five r times 5r is 25r squared. 5r times negative 4 minus 20rs. Negative 4s times 5r minus 20rs. Negative 4s times negative 4s. Negative times negative is positive. 4 times 4 is 16. S times s is s squared. So this is, when we simplify it, it's going to be 25r squared minus 40rs plus 16s squared. Now we need to rewrite it in a way with what we are given. We are given that 25r squared plus 16s squared is equal to 8. So we have 25r squared plus 16s squared. So we're going to group them in a bracket. And then minus 40rs. What is 25r squared plus 16s squared? We're going to put 8. So this is going to be 8 minus 40. Where is rs? We put negative 1 over 5. 8. Negative times negative, positive. 40 times 1 over 5 is 40 over 5, which is 8. So the final answer is 16. Right? I hope that makes sense. Alright. Even if you use the long method of simultaneous equations, I promise you'll get to the same result. Number 5 states, solve for x without using a calculator. Roman numeral number 1. When it says without using a calculator, it means if the answers are in fraction form, you leave them in fraction form. The final answers, no decimals. So Roman numeral number 1, you have 2 over 3x plus 1 is equal to 5 over 7x minus 4. Here's my pencil. So we're going to cross multiply. Okay, it's going to be 2 times 7x minus 4 is equal to 5 times 3x plus 1. 2 times 7x is 14x. 2 times negative 4 minus 8 is equal to 5 times 3x is 15x plus 5 times 1 is 5. Remember, variables on the left, numbers on the right. So we already have 14x. 15x, when it goes to the other side, it becomes minus 15x. On the right, we have 5. Negative 8, when it goes to the other side, it becomes positive 8. 14x minus 15x is minus 1x or minus x. 5 plus 8 is 13. Divide both sides by negative 1. X is negative 13. You can verify it on the calculator. Roman numeral number 2, 3x squared is equal to 31x plus 22. So if it's like this, it's a quadratic equation. Remember, you must write it in standard form. So ax squared plus bx plus c is equal to 0. 3x squared minus 31x minus 22 is equal to 0. Now can we factorize this? 22 is 2 times 11. 3x squared is 3nx. 3 times 22 is 66. 3 times 11 rather is 33. 33 minus 2 is 31. So we can factorize it. 0. Okay, so 3x x. Remember we said 3x times 11. So 11 will be here and 2 will be here. And then you give the bigger number the sign of the middle term. 11 is bigger than 2, so negative, positive. 3x plus 2 is equal to 0, or x minus 11 is equal to 0. 3x is equal to positive. When it goes to the other side, it becomes negative 2, or x is negative 11. When it goes to the other side, it becomes 11. Now we solve this. 3x over 3, negative 2 over 3. So the final answer is x is negative 2 over 3, or x is 11. Now here you need to verify with both of them. You need to get the same result, right? I verified, so they're both correct. Okay. Roman numeral number 3, open bracket, 5 over 2, close bracket, to the power of 3x plus 1 is equal to 16 over 625. So 5 over 2 to the power of 3x plus 1, 16 2 to the power of 4 over 625 5 to the power of 4. Okay, now we can see on the left we have 5 over 2, on the right we have 2 over 5. So we invert the right to match the left. 5 over 2 to the power of 3x plus 1 is equal to, when it goes to the up, when it goes up, it becomes 5 to the power of negative 4 over 2 to the power of 4, and it goes down 2 to the power of negative 4. Okay, so it's going to be 5 over 2 to the power of 3x plus 1 is equal to, now if it's like this, you reverse the exponential distributive law, right? So since it's the same exponent, you're going to take it out, negative 4. And then you write them as they are. So in the numerator, you're going to have 5 over, the denominator, you're going to have 2. Now the bases are the same, so you equate the exponents. Okay, 3x plus 1 is equal to negative 4. 3x is negative 4 minus 1. 3x is negative 5. Then you're going to say negative 5 divided by 3 is negative 5 over 3. So x is negative 5 over 3. Now I hope that wasn't too challenging. This is just a preview of part 2. So it will focus mainly on equations and inequalities. If you found this video helpful in any way, please click the like button and subscribe for more content. Thank you very much, and I hope to see you again.